it's way up above it. So I don't know. All right, 3-8. Solving systems of equations using inverse matrices. Can you get the door? All right, we'll start with the identity matrix. The identity matrix is a square matrix. That when multiplied by another matrix results in the same matrix. So what do you think a square matrix is? Okay. Only a 2 by 2?
Same column, same row.
Same columns, same rows. They gotta have the same number of columns that they have of rows. Who sits in front of you, Macy?
Ellen, Patty, and Jaden. Kaden.
So let's look at the 2 by 2 identity matrix and the 3 by 3. The 2 by 2 is 1, 0, 0, 1. Three by 3 is 1, 0, 0, 0, 1, 0, 0, 0, 1. So it said that if we multiply a matrix times the identity matrix, we should get itself, right? So if I have A, B, C, D, and I multiply that by 1, 0, 0, 1, I should result in A, B, C, D. And to be inverses, two matrices multiplied together will result in the identity matrix. Two matrices are inverses. If their product is the identity matrix. Meaning the matrix times the inverse matrix would result in 1. Matrix. And I don't have enough room to squeeze the first example in, so I'm going to have to change my paper here. Got it? Okay. So we're going to look and see, are these inverses? Oops. Got A that is -4, 2, -2, and 1. And B that is 1/4, -1/2, 1/2, and -1. So I'm going to multiply A times B to see if it results in the identity matrix. Everybody with me? So I'm going to take A, which is -4, 2, -2, and 1. And I'm going to multiply that by 1/4, -1/2, 1/2, and -1. And how do I multiply them? Rows to columns. So -4 times 1/4 plus 2 times 1/2. That was row 1, column 1. Now I'm going row 1, column 2. -4 times -1/2 plus 2 times -1. Now row 2, column 1, -2 times 1/4 plus 1 times 1/2. and negative 2 times negative 1/2 plus 1 times negative 1. Everybody still with us? All right. Gonna simplify here. Negative 4 times 1/4 is negative 1, plus 2 times 1/2 is positive 1. Then I've got negative 4 times 1/2, that's positive 2, plus negative 2. 2 times negative 1 is negative 2. Then I have negative 2 times 1/4, that's negative 1/2, plus 1 times 1/2, that's positive 1/2. And then negative 2 times negative 1/2 is positive 1, plus 1 times negative 1 is negative 1. So now one last simplification. Negative 1 and positive 1 make 0. 2 and negative 2 make 0. Negative 1/2 and 1/2 make 0. And 1 and negative 1 make 0. Did that make the identity matrix? No, the identity matrix would have a 1 here and a 1 here. Okay, it didn't create an identity matrix, therefore A and B are not inverses.
Can you repeat that again?
Because it did not make the identity matrix, that 1, 0, 0, 1 matrix that we wrote on the other side, then these two are not inverses. All right, you guys try this one. See if you can determine if they are inverses or not. So I've got 3, negative 5, negative 2, and 6. And then I've got 3/4, 5/8, 1/4, and 3/8. See if you can follow those same steps, multiplying the 2 by 2 matrix to see if you come up with the identity matrix or not. So looking at this problem, the practice problem, the most important thing is getting everybody plugged in where they go, right? That's the most important thing. You can get that, then the calculations are very easy. You should have ended up with 9/4 and negative 5/4, 15/8 and negative 15/8, negative 6/4 and 6/4, and negative 10/8 and 18/8, which resulted in a 1, 0, 0, 1, which resulted in F and G being inverses. Yes? Questions? Okay. Let's talk about the inverse and how to actually find an inverse given just the matrices. Now we can determine if two things are inverses. Can we determine what the inverse is? So it says the inverse of a matrix A, which is A, B, C, D, is A inverse equal to 1 over this AD minus BC. Where have you seen that before? What is that? What is the AD minus BC? AD minus BC. What is that? The determinant. So I need the determinant. So 1 over the determinant times the matrix of, here we go, D and A switch places. Not DNA, D and A. I can't get ready to laugh on that one. I don't know what's wrong. Maybe it's my delivery is off. I don't know. All right, and then the opposite of B and the opposite of C. So D and A switch places, and then the opposite of B and the opposite of C, where your determinant cannot be 0. Why? Because it's in the denominator, right? Can't be 0 because it's can't divide by 0. Yes? Okay. Holy cow. Let's do practice. On the screen a little bit. I have the matrix P that is 7, -5, 2, and -1. I'm going to tell you guys, the first thing I'm going to do is there's a whole lot of A, B, C's, and D's going on in this mix-up of the inverse. So I'm going to label my initial matrix A, B, C, D. I think your mom's calling back. Nope, not yours. Must be somebody else's mom. Killer. All right, so we have A, B, C, and D. Everybody with me? Okay. So then I can start looking at the determinant. You remember how to find the determinant? How did we do that? 7 times who? -1 minus -5 times 2. So I have -7 minus -10. So that's plus. So that means -7 plus 10 is 3. All right, so the A inverse is 1 over the determinant. My determinant is 3. And now I got to make some changes with my matrix here. Who switches places? Okay, so who goes first? So -1. What do I do with B?
You make it a negative, so it'd be positive.
So I do the opposite of what it is. So it is +5. What about C? -2. And then last, 7. The A is switched with the D. All right. How do I just multiply this scalar multiplication? I'm just multiplying every position by 1/3, right? Okay, so 1/3 times -1 would be -1/3. 1/3 times 5 would be 5/3. 1/3 times -2. -2/3, and 1/3 times 7. Just 7/3, right? No negative there. And that's my inverse.
I
Ta-da.
don't understand. Just be easy.
I said ta-da.
Okay. I don't understand the part that goes next to 1/3.
This right here,
But not the.
this part.
Yeah.
We followed this scenario. So D and A switch places. So I had D and A here, so I switched them here. They have opposite signs. I need to do the opposite of B and the opposite of C. So -5 became +5. +2 became -2. Any other questions? Okay. You got this? Okay. Okay. Try this one. Try that one.